And welcome to the Daily Space Weather Smasho here, coming at you from the Smash News Network, least supposed to name of news, bringing you the most detailed imagery of the sun you'll find anywhere in the world, and the most comprehensive space weather videos, period, in the known universe. What we're seeing here is DAG, possibly the largest coronal mass ejection of solar cycle 25. It's certainly significant. Interestingly enough, that filament was named after me. We've been naming filaments after living people. And let's take a look at some more imagery of that. Is it earthly directed? We'll let you know later in the video. Here's a close-up. We've actually slowed this down. We usually show 30 frames per second. This time we're showing 15 frames per second, since there is so much activity occurring in that location. So fantastic imagery there. Some plasma splashing back down toward the chromosphere. Some plasma escaping into the greater solar system. By the way, that's ionized helium plus iron. Let's go around the horn since there is a filament fest going on. And by the way, welcome to the North Pole. Yeah, the North Pole. The North Polar heliosphere, since most of the sun's north pole-oriented magnetism is currently pointed toward Earth. So still a long way to go to solar maximum, folks. Huge snaky filament there as well. Quite lengthy indeed. Here's the northeast. There is a new sunspot that just rose right up here. That is already a sunspot, so we'll have at least one new named sunspot group today. And here is the northwest. Let's take a brief look at sunspots before we do some earthly information. So let's see. We've got growth of this sunspot group. We've got growth here. We've got some umbral migration here and a little bit of degradation. So lots of activity here continues in the northern hemisphere. And don't forget to keep your eye on these two groups, because these two groups are certainly capable of producing very large flares. There is a plasma bridge between them. Their magnetic fields may even be amplifying each other, but there is a lot going on right there. And as those two parallel groups set, don't be surprised to see X-class solar flares. Let's take a brief look at Croissant Earth to see what's erupting. By the way, this imagery here, that is Stromboli. I think we have to name a volcano Calzone. Anyway, Stromboli continues to erupt there. There's a lava flow shown in the image. No significant variations in the volcanic tremors. Subanose Jima is erupting, producing a 6,000-foot volcanic ash plume, flight level 060. Flight level 140 over Semaru as it explodes. Pavlov has stopped erupting. That's on the Alaskan Peninsula. Popocatépetl continues to explode, produce a 20,000-foot ash plume over central Mexico. Flight level 200, Fuego in Guatemala. Mild explosive activity. No indication of the ash plume size or flight level. Flight level 200 over Sangay in Ecuador as it explodes. And a 19,000-foot ash plume over Revenador, flight level 190, flight level 240 over Sabancaya in Peru. It appears to be the largest ash plume in the world as Sabancaya explodes. Also some emissions noted there from Villarrica. And let's take a look at earthquakes next. We have had a significant quake in the past 24 hours. It was located deep into the South American continent. A fairly uncommon place to see a quake of that magnitude. That's the past 90 days from volcanodiscovery.com. And there is the location of that Argentinian earthquake. Well to the east of the Andes. Deep into the South American continent. So that's the location of that. That 6.8 magnitude quake came in at 9:39 Universal Time yesterday. I'm sorry, 2209 Universal Time yesterday. 2209 Universal Time. We had a 6.8 at Argentina. And let's just scroll up the list here. We'll see what else has been quaking. Not a lot of quakes here, but some significant ones here over a 5 magnitude, like this 5.4 at the Kermadec Islands there, northeast of New Zealand, a 5.0 in the Molucca Sea there, near Indonesia, Papua New Guinea, etc. Now, keep in mind that 6.8, that occurred at 610 kilometers estimated depth. If that would have happened at the surface, that would have been over an 8 magnitude earthquake. And keep in mind, folks, I say it all the time, any earthquake can be a foreshock. Like this 5.1 at Indonesia. South Sandwich Islands also had a 5.0. That occurred this morning at 5:47 Universal Time. And let's get back to space. And before we do that, let's take a moment to handle station identification. You've reached the Smash News Network least busted name in news. Congratulations on realizing the channel exists. Today's featured product is the Galactic Federation Special Forces motto, which is Universum Liberate. Now, I'm wearing it. Have you become sick of what's going on in your household, village, city, county, state, region of your country? Are you fed up with what's going on in your entire nation, perhaps? Are you sick of what's going on in your hemisphere? What about your planet, solar system? Well, if you're sick of what's going on in the whole galaxy, make sure you support the Galactic Federation Special Forces. Tell your friends and foes, Universum Liberate. If I could wave my magic wand, I'd set everybody free. Does that sound reckless? Well, I'm terribly sorry. Don't worry, Big Tech will do their best to prevent our videos from appearing on your screen. As all entities yearn for freedom. Once again, Universum Liberate links below the video to the Redbubble shop. If you click them, you will find the products in order of best-selling. Universum Liberate is like our, 5th bestseller or something like that. So check out the merch. The print quality is very high. And we've made lots of different designs here because reasons. And congratulations on surviving a global scamdemic so far. You're doing a fine job. Press like and subscribe if you enjoy the content on YouTube. Make sure you check our playlists if you haven't. Playlists. Yes, you can see all kinds of additional stuff there, like smashomash.org presents The Sun, The Diamond Anvil Too Hard to Smash, Terms Defined, and lots more. Do one thing. Click playlists and check out our other content. Thanks to everybody who's tolerated the pathetic and putrid censorship on the YouTube platform. We are also on Patreon if you'd like to support the channel. There are 3 membership levels there on Patreon. That's mainly for donating. If you want additional content, become a member of the Smash Team at smashomash.com/Smash Team. It's the official subscription services site. If you want additional content, if you want to know what's driving the solar sunspot cycles, become a gold member. If you become a gold level Smash Team member, we will tell you the basis for the paper that we're writing, which is to explain the solar sunspot cycles. Science is weird, folks. It's a rabbit hole. And when you enter the rabbit hole, you ask questions. And oftentimes you receive answers to questions not asked. Oftentimes you don't receive answers to questions that were asked. And oftentimes you don't receive answers to questions that were asked. But that's what happens. You just have to go with the facts. So sometimes you make discoveries that you didn't even want to make, which might creep you out big time. That's what's happened in this situation. I don't necessarily like the hypothesis of the mechanism underlying the solar sunspot and solar polar field reversal cycles, but it appears to be the case. So I've been trying to disprove my own theory for a couple of years now, at least about a year and a half. And welcome to the Neo-Renaissance. Congratulations once again on realizing the channel exists. Let's get back to space. So, in our efforts to bring you the most comprehensive space weather content in the world, as well as the most detailed imagery of the sun, here is one of our new favorite wavelengths. This combination is two different species of ionized iron, 171 angstroms plus 335 angstroms. We'll also show the 211 plus 171 angstroms. Great at showing that CME in the southwestern limb. That is good stuff. And the 10.7 centimeter radial flux has actually dipped down to 218 solar flux units. No real surprise there. We saw a bunch of major sunspot groups set, but we've got some more rising here. So let us know in the comments what your theory is. Do you think the radial flux is going to continue to dip, or will it rise even higher? Again, I've been saying it for a long time now. We're nowhere near solar maximum. So all of the shall we say, interesting channels that, quote, cover and, quote, space weather, a lot of them seem to have thought that we were at solar maximum. It's not the thing, and neither is a grand solar minimum. Next, we are looking at the Space Weather Enthusiasts dashboard here. That's NOAA's forecast for geomagnetic conditions, the Earth's magnetism. That's the KP index, the planetary K index as it's otherwise referred, and no geomagnetic storms or unrest forecast here. I would say that there is going to be a CME impact. It'll be a minor one sometime after midday tomorrow on January 22nd. We'll have to see what happens. I expect to see a KP4 or 5 event for a short period of time, like maybe 6 hours. It all depends on the magnetic fields. But we certainly thought that we saw an Earth-directed coronal mass ejection. We'll have to see what happens. And we're right on this slightly more often than NOAA, I believe. Let us know in the comments what you think about our forecasting of CME impacts. It's not really my strong suit, but it's one of those things that comes up in the scope of doing this job. So the planetary K index here, a measurement of global geomagnetism, is currently at 2. KP2, geomagnetic calm conditions. We did briefly reach geomagnetic unrest conditions early this morning. We'll tell you why here in a minute. First, let's take a look at Earth's magnetic moment from space for the past 4 hours. That's our Geospace Magnetosphere movie. If you want to learn more about it, click on the Details tab down here. That will tell you, that'll give you a link to the Space Weather Modeling Framework, which is how these models are derived. Here's Earth's magnetic moment from the ground. It'll show you the most likely places for pipeline induction, power line, and railway induction. Also, the most likely places to see the aurora. That's ground magnetic perturbations for the past 4 hours. Earth's magnetic moment from the ground. Geospace delta B changes to Earth's B field, the B field being the field that goes through the magnet, this magnet being Earth. So looking at the real-time solar wind, here's why we got into geomagnetic unrest conditions. We had a strong negative BZ. So you see that red line there? That's the vertical component of the magnetic field. And when that gets negative, that tends to induce more currents on the planet, which raises the geomagnetism. So yeah, KP4, we did have brief geomagnetic unrest. And we do have an elevated solar wind speed here. Once again, it's 509 kilometers per second. Solar wind density just under 11 protons per cubic centimeter. And if we see that strongly go negative again, we'll go right back into geomagnetic unrest or even geomagnetic storm conditions, depending on the field strength and on changes to the solar wind speed and or density. Now we'll look at magnetic data. The GOES magnetometers there showing some rather rapid dips. And that is something that we regularly see, some wild variations when we see incoming plasma. So when we see, for example, CME impacts, coronal mass ejections, when we see coronal hole high-speed stream impacts, we see spiky readings on the GOES magnetometers. And you can see it's been pretty spiky here. We've got a lot of coronal holes. And let's take a look at the heliospheric current sheet next. So now when I said welcome to the North Pole, it's because most of the North Polar magnetism is in the earthly facing zone. So there's the North Pole heliospheric current sheet. Here on the opposite side of the sun is the South Pole heliospheric current sheet. It's pretty well defined here at the moment. So yeah, welcome to the North Pole. And this is what it looks like from the North Solar Pole. You can see the way the sun's B field, it looks like it's fanned out here. That's because the North Solar Polar Field is largely directed right towards your doorstep. So that stopped playing because reasons. And let's just refresh that. That's the Sunsby field in blue. North polar field in green, south polar field in red. And next we'll look at coronal holes. So interestingly enough, we've got North Pole magnetism fixated up here in the North Polar region. South Pole magnetism fixed down here at the South Polar region, indicating that there's a long way to go to get to solar max, as the fields need to reverse. And frankly, they're still not even halfway there. So when they're halfway to the reversal, when they're halfway to their opposite respective poles, that's what you'd call solar maximum, and we're not there yet. This is a more definitive feature than the sunspot number or the radio flux, in my opinion, as there is an inverse proportional relationship between the solar polar strength and the solar equatorial magnetic strength. We won't talk about it too in depth in the video. That's something to talk about with only Gold Smash Team members. So here are coronal holes as viewed from SDO. And again, these are all North Pole oriented. This one down here is South Pole oriented. And let's move to sunspots. Oh, and by the way, we can expect a powerful geomagnetic storm condition in about 4 days from this coronal hole. It's transequatorial, which means some of the high-speed wind coming out of that coronal hole will be reaching Earth, maybe even causing some auroras where you're located. Next, move to sunspots. We've got at least one new group rising here. That'll be 3200. Yeah, sunspot 3200. It's right there. It just rose. It'll definitely get a name as it is quite significant. It will likely be there a lot more than 12 hours. Let's take a look at sunspots. Here you can see that bright active region rising there. That's sunspot 3200. So here's the SDO magnetogram. You can see that field just rising in the northeast. And let's zoom in a little closer here to show any changes happening here. Most of these sunspot groups are largely stable. Like I said earlier in the video, there is a little bit of growth and a little bit of degradation. For the most part, fairly stable sunspot environment there. And let's move to energetic particles and solar flares next. So check it out. We did see some spikes in the proton flux there. Some little minor spikes in the proton flux, ending just after midnight. Let's take a look at flaring. Flaring has been minimal. We are seeing a little uptick here in the past few hours, but in the past 7 days, a bit of a downtick there in flaring. Let's take a look at the two best wavelengths through which to view flares from SDO, 94 angstroms, which takes 10 images per minute instead of only 2 images per minute. And here's 131 angstroms, which also takes 10 images per minute. These are both portions of the extreme ultraviolet wavelengths. They're not visible from the ground level. They have to be viewed from space. Earth's atmosphere filters out these frequencies of ultraviolet light. They're very specific bands of ionized iron. And let's take a step back and see what's going on over our heads at Lehigh Valley, Pennsylvania. So if you just click the Now button, it'll update on your skyandtelescope.org star chart if you make one for your location. Of course, we're looking into the southeastern sky here, and it's too light to see anything, but if you are up before dawn, you might see Mercury rising ahead of the sun. And let's do a solar system forecast. So, tomorrow is new moon. Shout out to all my reverse werewolves. May you sleep well and not cannibalize humans or worship Satan. Let's advance this 1 week. Here's where things will be in a week. We will still have a crescent waxing moon as Earth moves to a very lonely side of the solar system, a side devoid of gas giants. Next, looking at some coronagraphs, and obviously they are quite spectacular here. Let me just press refresh on that. So major CME happening there. Does it have earthly directed components? Well, we'll let you know here in a minute after we do further analysis before your very eyes. That's 78 frames from yesterday at George Mason University. And here are today's frames. No CMEs so far, and let's take a look at stereo A at Lagrange 5 and Soho Lasco C3 at Lagrange 1. Now we've paused it here at 1603 for Soho Lasco C3. And for you new viewers, from this perspective, Earth would be behind you. From this perspective, at stereo A, Earth would be off to the right. And so if we let this play out, let's just advance this manually. We don't see any components of that on the Earth line. Not likely to be an earthly directed coronal mass ejection. If you look at it from the Soho Lasco C3 perspective, you can see no halo there. That appears that it will all miss to the southwest. There could be a tiny component. If that does strike Earth, it will be a minor coronal mass ejection impact. And let's just let these play through here. Keep in mind they are not synced, and pay attention to the date stamps as they are both 90 frames, but it's a different series of times there. They are pretty well synced. Great imagery there. And let's take a look at some even greater imagery. DAG. Fantastic composite there showing Soho Lasco C2, C3, and the SDO ionized helium 304 angstroms wavelength. And that could be considered a money shot. I'm a little disappointed that it's not earthly directed. I know some people on YouTube might have told you that if that was earthly directed, it would be time to get into your bunker. Because reasons. I just want to see the aurora in Pennsylvania. So, yeah. Hoping for CME impacts on Earth. Not frightened of them. And, so yeah, that's the last 24 hours. Good stuff. Next, let's talk filaments. Since the likelihood of additional coronal mass ejections is very, very high, we've got lots of filaments here, as seen from El Teide, Spain's ground-based solar observatory. Most of them are now in the northern hemisphere, and I've lost track of the names. Of course, the filament that was named for me is, whoops, now flying through the solar system to our southwest. But yeah, we've lots of filaments there. And if you want to name filaments after living people, hit us up on Twitter. If you don't have a Twitter account, why not? Get one. No, censorship is not fixed. However, we need people like you to share the videos. And yeah, look at the numbers here. We've got 371 followers. We've been on Twitter since March of 2019. And we've got over 18,000 tweets. Original daily content, our own series of websites and businesses that we run. And yet 371 followers. Sounds strange? Yeah, it's definitely strange to say the least. So we streamed this CME yesterday, since it was so splentacularly, deliciously ridiculous. Just a fantastic CME happening there. What's great about the Go 16 SUVI is it has a very wide field of view. And if you want to grab some of that footage yourself, head to twitch.tv/smashomash. The location at which we regularly do live streams. So here's the last 24 hours from SDO in ionized helium. And here's the last couple of hours from the GOES 16 SUVI. Another CME happening up here. So lots of stuff happening here. And shout out to Julie, who has named this filament James Comer after the Kentuckian politician. Is he a congressman, I think? Congressman, senator, something. So definitely lots of activity here to cover. It'll be an interesting couple of years for space weather. And that brings us to our bonus feature segment. So we've got some satellite charging hazards here. There are minor surface charging hazards over the Central Pacific Ocean. Nothing to worry about. Let's take a look at the electron flux. There are your relativistic electrons as measured by the GOES 16 and GOES 18 at their geosynchronous orbits. Using radiography, they measure the relativistic electrons down at the F layer of the ionosphere. That's your 3-day electron flux. And it looks like somebody might agree here, as we've got this forecasted dip in the electron flux coming tomorrow. So that is what we would expect. I would agree with that forecast, as we could expect to see. Oh, wait, that's today's forecast. Anyway, we are expecting a dip in the electron flux as a result of a coronal mass ejection impact, which we're expecting by midday tomorrow. Here's the 1-year chart to put it in context. That is your relativistic electrons over the past year, reported by Solon.info. And let's take a look at the F layer of the ionosphere, the bridge between Earth and space. So there it is. It's at about 300 kilometers of altitude. This is the vibrational frequency in megahertz, millions of vibrations per second. And it has been quite anomalous here for a few weeks. In fact, I'd say over a month, we've been noting major anomalies to the point where this map has appeared, well, actually the anomalygram has appeared on our thumbnails. So here is the anomalygram. This is anomaly in megahertz from a 30-day median. And yeah, the South Atlantic anomaly is now in the South Pacific. We've been saying it for weeks. It's right about where my pointer is now instead of up here over South America. And the South African anomaly is now right near the equatorial west coast of Africa, right where my pointer is here. So that's interesting, as these features have migrated a massive distance and then stopped at their new locations. If you've got theories as to how Earth's magnetic dynamo is generated, leave them in the comments. We are aware of the mainstream explanation of how Earth's magnetic dynamo is generated. Anyway, there's the latest image. That's 12:30 Universal Time ionogram and 12:30 Universal Time anomalygram. Next, we've got the total electron content forecast, which has been very anomalous as well for a month plus, maybe at least 3 weeks plus, something like that. It's the free electrons between your GPS satellite and your handset. Those red areas are the most likely places to see GPS errors. And note this anomaly over the northeastern Caribbean. That has been there for a long time. Also, this anomaly down here. And also these low electron content bands. Very odd. Once again, that is the free electrons from ground level up to about 12,500 miles of altitude. Those free electrons cause signal refraction. And those are the most likely places to see GPS errors. You can expect lots of GPS errors here on a worldwide basis. Total electron content, highly anomalous for an extended period of time. Last but not least, we'll close out the space weather segment with the latest magnetogram and latest colorized and latest intensitygram. So there is our colorized magnetogram and intensitygram. Again, new sunspot, that's sunspot 3200, as far as I can tell. There's the full disk rockback. Possibly a new sunspot forming down here. Not showing up yet, just a plage so far, folks, just a plage. And once again, I would note that this location right here is very likely to produce an X-class solar flare. So don't be surprised to see that happening. There is a huge plasma bridge and a plasma exchange happening here between these two sunspot groups. They're lined up right on either side of the solar equator. There are a lot of chaotic forces in between there, and a lot of plasma switching back and forth. If either of those sunspots suddenly changes, expect a major flare. So that's where the space weather segment ends. And let's move to our meteorology segment. The first thing we're looking at here is the mean sea level pressure. So got a very strong low pressure here in the North Pacific. Interestingly enough, the winds aren't very strong. So that's kind of weird. We've got the surface winds there as well as the mean sea level pressure. Surprisingly low winds there despite very low pressures. I mean, when we look at the Southern Ocean, that area there is of similar pressure. What the heck? How are the winds? Something doesn't look right there, folks. Look at that. 9 miles per hour? That's impossible. What is up with that? I don't know. That's awfully slow winds for such low pressures. Anyway, let's check wave height while we're here just to see if there are any other issues with the data. So we'll do ocean, significant wave height. It looks like things are pretty calm. Okay, we've got nearly 50-foot waves in the Pacific Ocean. 45.9-foot waves. I suspect the winds might be a little bit higher than reported there. Those are some of the biggest waves we've ever reported on the channel. 45.9-foot waves there. That is interesting indeed. All right, so let's switch to our regular wind maps here. Here is the surface wind scenario for the... Oh, there we go. Now it's showing up at 61 miles an hour. That makes more sense. Yeah, 61 mile an hour winds. What do we have down here? Low winds. That's very odd. Usually you'll have high winds associated with those low pressure zones. Anyway, these are the surface winds of the eastern world. These are the jet streams. Here are the jet streams of the Americas. Some cold air being injected into the Rocky Mountains once again, making it all the way down to Arizona, New Mexico, and indeed Mexico proper. Surface winds of the west are looking like this. Surface winds of the central world are looking like this. It's another bad day for Viking raids, by the way. We've got strong winds in the North Sea. If you're rowing a longboat, well, you'll be fine. You're a Viking. Anyway, those are the jet streams of the central world, and let's move on here to take a look at clouds and fog over the Americas. So as the sun rises there over the eastern portion of the two American continents, that is what's going on in terms of clouds and fog. The 3.9 nanometer infrared radiation satellite. Here's our weather.gov map. If your area is lit, click your location. We've got some gale warnings and things for the East Coast, it looks like. We'll scroll down briefly so you can see the key. What the heck is that? Is that hard freeze warnings in the ocean? Oh, storm warnings, right. All right, so we've got some interesting forecasts for you here again. If your location is lit, click your location on the weather.gov map. We can't cover all of those counties. Those are too many counties to cover. And let's take a look at winds. So we're expecting some very significant winds to form. There's going to be a low that forms off the coast of New Jersey here, and right there. And then the pressure's going to drop a little bit as it moves up New England. So that's our GFS 72-hour mean sea level pressure and wind forecast. Let's take a look at total accumulated precipitation next. It's the same model, the GFS 72-hour precipitation listed here in inches. Some of that precipitation will fall in the form of snow. So let's take a look at that as well. Well, here is pressure and precipitation. So that low is going to get quite strong there. Some severe weather coming for Cape Cod. And let's take a look at snow depth accumulation. So this is the accumulated positive snow depth change, also in inches, based on the same model, the GFS 72-hour forecast. And some minor snow there coming to Pennsylvania. Looks like nearly all of New York is expected to be coated, and nearly all of New England. Hopefully that helps your forecast planning. We'll also show the European forecast for snow for the next 3 days. So there's the next 12 hours. The areas there east of the Rockies expected to see some snow the next 24 hours. Heaviest snows there showing up in Kansas. And there are the next 3 days. If you're interested in the difference between the GFS and the European model, that's the European model. There is the GFS model. Expecting some significant snow all the way down into Mexico. Really both models. You can expect to see some Mexican snow here, not the most common thing. That's a 3-day forecast for the European and GFS models. Next, NASA goes lightning mapper, and we've got some lightning over Louisiana here in the past about 12 hours. Let's see if we have any terrestrial strikes. Looks like we've got some Gulf of Mexico lightning happening. Some lightning there off the coast of Galveston. Anyway, that's your real-time lightning map. Check it out next time you hear thunder, perhaps. And let's continue on to our U.S. Doppler radar map. We like to show all 50 states of AUSA briefly and then focus on the lower 48. Some strong storms there, just north of Nolens, moving into Alabama, Georgia, etc. Here is our shortwave radiation map showing clouds and fog. And there is the water vapor map. Looks like clear skies over much of Texas there. So we've got dry, massive air over most of the Lone Star State, which is effectively a high-pressure system, relatively speaking, compared to the moist air around it. Here's your recap. U.S. Doppler radar. Ground-based systems that show vertical motion in the air column. Shortwave radiation satellite showing clouds and fog when it's too dark to use the visible satellite over most of the country. And last but not least, the water vapor map. Some rapid cloud nucleation happening there in the Gulf of Mexico. Anyway, that's about where we'll shut this thing down. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.